Microplastics and cancer risk. Explained. What do we know about microplastics and cancer? Microplastics are increasingly discussed in relation to human health, including cancer. But what does the science actually show? And what remains uncertain? In this video, we'll review what microplastics are, how humans are exposed, what current research suggests about cancer risk, and where evidence is still emerging. What are microplastics? Microplastics are plastic particles smaller than 5 millimeters. They come from the breakdown of larger plastic products and from manufactured sources such as synthetic textiles, tire wear, food packaging, and personal care products. An even smaller category, nanoplastics, may be capable of crossing biological barriers, although this area is still under active study. How are humans exposed? Humans are exposed to microplastics primarily through ingestion and inhalation. Microplastics have been detected in drinking water, bottled beverages, seafood, fruits, vegetables, and table salt. They are also present in indoor and outdoor air, particularly from synthetic fibers and dust. Studies estimate that the average person may ingest or inhale tens of thousands of microplastic particles each year, though exact exposure levels vary widely and are difficult to measure precisely. What happens in the body? Research shows that microplastics can be detected in human tissues, including the gastrointestinal tract, blood, lungs, and placenta. Laboratory studies suggest microplastics may induce inflammation, oxidative stress, and immune system activation. Some plastics can also carry chemical additives or environmental pollutants, which may contribute to biological effects. However, detecting microplastics in the body does not automatically mean they cause disease. Microplastics and cancer. What do we know? At present, there is no direct clinical evidence that microplastics cause cancer in humans. Most cancer-related concerns come from laboratory and animal studies, where high concentrations of microplastics have been shown to promote inflammation, DNA damage, and cellular stress, processes that are biologically linked to cancer development. Additionally, certain chemicals associated with plastics, such as bisphenols and phthalates, have been studied for potential endocrine and carcinogenic effects. Importantly, these findings do not prove causation in real-world human exposure. What remains uncertain? Several key questions remain unanswered. We do not yet know what level of microplastic exposure, if any, increases cancer risk. We also do not know whether long-term, low-dose exposure behaves differently from short-term, high-dose exposure studied in laboratories. Large, long-term human studies are needed to better define health outcomes. Practical risk reduction without alarmism. While evidence is still evolving, some reasonable exposure reduction strategies include using glass or stainless steel food containers, avoiding heating food in plastic, reducing reliance on single-use plastics, and improving indoor air filtration. These steps are precautionary and not a substitute for evidence-based cancer prevention strategies such as vaccination, smoking cessation, and cancer screening. Key takeaways and conclusion. In summary, microplastics are widespread and detectable in the human body. Laboratory studies suggest biological effects that warrant concern and further research, but there is currently no direct evidence linking microplastics to cancer in humans. Ongoing research will help clarify long-term health implications. As always, medical decisions and cancer prevention strategies should be guided by high-quality evidence and discussed with qualified healthcare professionals. We need more research evidence evolving. No proven causal link to cancer in humans. Educational purposes only.